Bio-30s, I'm back again for another lesson. Just had to get some quick reps in, get my metabolism going, as I'm going to teach you about hormones that affect your metabolic rate. So the first hormone we're going to talk about today is thyroxin. So thyroxin is going to increase your metabolic rate. The stimulus for producing thyroxin would essentially be a lower metabolic rate. You'd want to increase your metabolism, and overall you want to increase the rate of cellular respiration. So you need a little bit more energy in your body. So here's how you're going to do it. This particular feedback loop involves the hypothalamus and pituitary. So if you remember from our last lesson, glucose hormones do not involve the hypothalamus and pituitary. Stress hormones, at least long-term stress, does involve the hypothalamus and pituitary. So we begin with the hypothalamus. It is going to release a releasing hormone. So we're going to have a releasing hormone. And that releasing hormone is going to then activate the anterior pituitary. Once again, this means the hormone is made, stored, and released by the pituitary. And this particular hormone is TSH. Now, TSH stands for the thyroid stimulating hormone. The nice thing about hormones is a lot of the names tell you what they're going to do, which is quite nice. So in this case, thyroid stimulating hormone is going to stimulate or activate the thyroid gland. So it's going to go into your blood. It's a targeted hormone. It's just going to target the thyroid gland, no other body cells. When the thyroid gland gets hit with TSH, it's going to produce another hormone called thyroxin, or also known as T4. Thyroxin is a non-targeting hormone because it's going to mostly affect most of your body cells, but in particular your heart, your muscles, your liver, your kidneys. Essentially all it's going to do is ramp up the rate of cellular respiration. So you're going to increase the rate of cell respiration, increase your metabolic rate, and overall increase your metabolism. This does have a byproduct of actually increasing your body temperature as well. Because if you remember from Bio 20, when we talked about cell respiration, if you took a glucose molecule, at best, 36-38% of it turns into ATP. The remaining is actually given off as heat. So if you increase the amount of cell respiration you do, you'll increase the amount of heat your body produces. Now, just like our other feedback loops, this is an example of negative feedback. So when your metabolic rate increases, it will feed back to your hypothalamus, which will then turn off the releasing hormone. This will then turn off the TSH from the pituitary because it's no longer stimulated to produce the TSH. And if there's no more TSH, the thyroid is not going to produce any thyroxin, and then our feedback loop would be closed. So once again, your metabolism is low. The hypothalamus realizes this, releases a releasing hormone to the pituitary. Pituitary makes TSH. TSH goes through your blood to your thyroid. Thyroid makes thyroxin, and thyroxin increases your metabolic rate. When you then have an increased level of thyroxin, or your metabolism is where it needs to be, we're then going to turn off the releasing hormone, turn off the TSH, and eventually turn off the thyroxin. Now, disorders you might have with thyroxin. The first one is actually not a thyroxin disorder, it's actually a thyroid disorder. It's called a goiter. So it's actually nothing really wrong with your hormones. It's actually a lack of iodide that causes the thyroid to enlarge. So you get a large lump in your throat due to the enlargement of your thyroid. So it kind of looks like this. Like I said, a normal feedback loop would be hypothalamus, pituitary, thyroid, thyroxin. That's a normal loop. But in order to produce thyroxin, you do need iodide. If you lack iodide, insufficient thyroxin is produced, meaning you won't turn off the TSH. Essentially, TSH just keeps firing at your thyroid, and your thyroid's not making any thyroxin, and that's going to cause your thyroid to grow. Treatments for this usually include some type of radioactive iodide, possibly some radiation and surgery to have it removed. So that's some treatments for a goiter there. Generally speaking though, if you have a balanced diet, you're probably getting the iodide you need, so it's probably not something you really have to worry about. Two disorders that are very, very common, so these disorders are quite a bit more common, would be hyperthyroidism and hypothyroidism. Hyperthyroidism would be an overactive thyroid, so you produce too much thyroxin. Hypothyroidism would be an underactive thyroid, you don't produce enough. So there's a lot of symptoms associated with both. I'll just go through a few here. So hyperthyroidism, you would have essentially an overactive thyroid gland. You'd have an overactive metabolism. You would have things like weight loss, rapid heartbeat. You would have difficulty sleeping. You would be very, very warm. You'd be sweating all the time, right? That extra heat production. You might have irritability, nervousness, muscle weakness. These are all some things that would happen if you have an overactive thyroid. An underactive thyroid, you may experience things like a slower heartbeat, weight gain. You might have fatigue, forgetfulness, muscle aches. You may be cold because you're not producing enough heat. So you kind of see the difference there between a overactive, underactive. Treatments would just depend on which version you have, right? If you have an underactive thyroid, you'd probably take some medication to increase your metabolic rate. If you have an overactive thyroid, you may take some medication to slow your metabolic rate, or sometimes people might even have to have their thyroid removed. That's usually more so in the case of thyroid cancer though. And if you did have your thyroid gland removed, which you could, you would then have to take medication for the rest of your life to manage your metabolic rate. Okay, and then the other hormone we're going to talk about today is HGH. I did show you this in my endocrine video as an example feedback loop, but here it is again. Hypothalamus kicks things off with a releasing hormone. So our releasing hormone is going to target our anterior pituitary, and the anterior pituitary is going to secrete HGH, which stands for the human growth hormone. Now, it's going to target most body cells. This is obviously a non-targeting hormone. It's going to affect your cells, increase cell division, increase protein synthesis, increase growth of bones, muscles, tissues. Essentially, you are going to grow. That's the job of HGH. It also does increase your metabolic rate, right? So it's going to increase the amount of glucose in your blood. It's also going to increase the amount of ATP as well. So it's also going to trigger the liver to release a IGF-1, which is called insulin-like growth factor 1, which is going to help you grow as well. So when you produce HGH in the early childhood, adolescence, this is when you would be growing through growth spurts. Eventually though, you're no longer going to be able to grow any taller. You'll still produce HGH, you just won't produce enough, you won't produce as much. You'll still produce enough, but you just won't produce as much. And you won't grow really any taller because your growth plates have fused together. So assuming you're going through a growth spurt here, once the growth spurt is finished, once again, we have a negative feedback occurring where we are going to turn off the releasing hormone, turn off the HGH, and then the growth spurt would then be finished. If you have too much HGH, so it doesn't turn off, you get a condition called gigantism, where you are going to grow very, very tall. The tallest person in the world, on average or on record, that had gigantism, I think he got up all the way to about 8 feet 11 inches before his death in his early 20s. But they looked at his body and they looked at his pituitary gland in particular, and it showed no signs of slowing down. So he was still going to be growing even more and more. So gigantism is basically your pituitary is not shutting off and you just keep producing HGH more and more and more and more. Dwarfism on the opposite side would be you lack HGH, so you produce an insufficient amount of HGH. And there is actually one more disorder. So I mentioned growth plates, right? If your growth plates were to fuse, so say you're a little bit older and your growth plates fuse, you're not going to get any taller, but you still have a hypersecretion of HGH, this can lead to something called acromegaly. Acromegaly would still cause things to grow, like hands, feet, sometimes your forehead, anything that's not, legs, limbs, arms, etc. They might still start to grow a little bit because of the excess HGH. So that's it for today's lesson. We talked about thyroxin and HGH, so two metabolic hormones. Next lesson, we're going to discuss some hormones that are regulating your calcium levels, as well as water and sodium. So thanks again for watching. We'll chat soon.